Okay, now we look at definition strong acid and weak acid. Strong acid will dissociate completely, which is 100%, and it will produce high amount of H+. For strong acid, the example are nitric acid, perchloric acid, sulfuric acid, HCl, HBr, HI, and chloric acid. So there are 7 strong acid and you should memorize this one. So when you want to do dissociation equation for strong acid, you need to use irreversible arrow. You can use the equation with or without water. If you use water, so the product will be H3O+. So HCl will donate H plus to water, so it produces H3O+. Without water, the product will be H plus. Okay, so this equation, we call it as dissociation equation, and this equation is very important for you when you want to calculate pH. Okay, so for strong acid, the value of alpha will be 100% dissociation. Okay, next we look at weak acid. So weak acid dissociates slightly. It will produce small amount of concentration H3O plus or H plus. Okay, so the famous weak acid will be CH3COOH, known as acetic acid. HCN, HNO2. So when hydrogen combine with group 17, HF is weak acid. HCl, HBr, HI are strong acid. Okay, so actually there are 7 strong acid. The rest of them will be weak. Okay, so for weak acid, it is not 100% dissociate. So that's why we will use reversible arrow. Okay, so same goes with strong acid. When you want to write down the dissociation equation, you can use water, or you can write down the equation without water. Next, we look at strong base. Similar to strong acid, strong base is 100% dissociate to produce high amount of concentration OH minus. Okay, so here we have metal come from group 1 and 3 metals come from group 2. So all of these metal can combine with hydroxide ion to produce strong base. Okay, so bear in mind magnesium hydroxide is weak acid. Okay, because magnesium is in group 2, but then magnesium is not in the list, so magnesium hydroxide is weak base. Okay, similar here, so this is a list of metal from group 1, list of metal, sums of metal in group 2. So when it combine with oxide, so it will produce strong base. Okay. However, for strong base, if the molecular formula, you can see clearly hydroxide ion, no need to add on water when you want to write down dissociation equation. Okay, for hydroxide, no need to write down water. Otherwise, your equation won't be balanced. Okay, so we have 2 OH here, so that's why it's produced 2 OH minus. Okay, for oxide, if you want to write down the dissociation equation, first, the oxide will react with water to produce hydroxide. So here we have 2 mole of KOH. So you need to start with 2 mole of KOH as well. So 2 mole of KOH dissociate to become like this. So we cancel this one and then we combine these two equations. So this is the dissociation equation for oxide. Okay. So similar with weak acid, weak base only dissociate slightly. So for weak base, we will use reversible arrow. Okay, so the famous weak base is ammonia NH3. So we can clearly see that NH3 has no OH. You cannot see OH minus. You cannot see the hydroxide. So that's why compulsory for you to add on water in the dissociation equation. Okay, so water will donate. So water is acid here, act as an acid, donate H plus to NH3. So becoming NH4 plus. So this one we call it as ammonium ion. Okay, so it will produce OH minus. Okay, so for ammonia, you need to add on water. If you cannot see hydroxide, if you cannot see hydroxide, so you need to add on water. So magnesium hydroxide is weak acid, so you can clearly see the oxide ion, so no need to add on water.